Hi everyone, welcome to our lesson on student loans. Part 1 of this lesson will focus on the question, why is college tuition over 100% higher than it was 20 years ago? To help us answer this question, we're going to use an Excel spreadsheet which is available for you on our course Blackboard site, and I'm going to go to it now. Okay, so here is the Excel spreadsheet that we're going to be working with that, as I mentioned, is available on Blackboard. And there are 2 tabs. The first tab that you see is labeled All Tuition Data, and this contains the average tuition and fees with and without room and board for a variety of college settings, starting in the year 1971, going up through the year 2019, and all of the amounts have been converted into 2019 dollars. The data was taken from the College Board website. And there's a lot of nice information on this tab, but maybe too much information. So if you go to the second tab labeled Private Public Summary, then what we see here are the highlights of the data for private and public institutions, with columns for tuition only and then columns for tuition and room and board. And this activity, we're going to focus on the tuition only columns, but if you like, you can go back and repeat this activity, including room and board as well. Okay, so the first thing we're going to do is we're going to create a scatter plot and a best fit line for our private 4-year tuition over time by doing the following. So I'm going to start by selecting columns A and B. Okay, so here's the data that I want, the data from columns A and B. I'm going to go up here to Insert, and I want a scatter plot. So in my chart, I'm going to insert a scatter plot. There it is. And then I want the best fit line for this data. So I'm going to come up here to Add Chart Element, pull it down, and go to Trend Line, and then come all the way down to More Trend Line Options. Notice I have linear selected. That's what I want, so I'm going to leave that alone. But I want to check the box for display equation on chart. And that's exactly what I need. And so here is our equation. I'm going to move it so we can see it a little bit better. So there's the equation for our best fit line. And so in your handout, question number 3, where it asks for the best fit line for our data, there it is. There's the answer to question 3. Okay, now we're going to do the same thing. We're going to create a scatter plot and a best fit polynomial for our public 4-year tuition only. So I need column A, and then I'm going to use my control button, hold down the control button so I can select just columns A and C. And I'm going to go back up to Insert. And the charts, I'm going to pull down so that I can get a scatter plot for this data. There it is. And then I want my equation, so I'm going to go up here to Add Chart Element, come down to Trend Line, and then More Options. And this time I want a polynomial, so I'm going to select Polynomial of order 2. And I'm going to check the box that says Display Equation on Chart. Okay, and so here's the answer to question number 5. Here's the best fit polynomial for our data. And so what's the common trend for these 2 graphs? Well, we can see that they're both trending upward, right? That tuition is becoming more expensive. Okay, so now I'm going to hop back over to our PowerPoint so we can work with this a little bit more. Okay, so here we are back, and here are our 2 scatter plots and best fit line and best fit polynomial that we found for our private and public four-year colleges, focusing only on tuition. And what we're going to do is we're going to use these models to predict the tuition costs for a student entering each type of institution in the academic year 2025-2026. And we're going to do that in the following way. Now remember that our equations, our data started in the year 1971. So the year 1971 for us corresponds to x equals 0. And so if we're interested in the year 2025, what x value will 2025 correspond to? Well, if you subtract 2025 from 1971, we'll see that 2025 is going to correspond to x equals 54. So let's evaluate the two equations that we found in steps 3 and 5, our best fit line and our best fit polynomial. We're going to evaluate those two equations at x equals 54. So for private institutions, there's our best fit line, and we're going to replace the x with the number 54 and do a computation with your calculator, and that will give you a prediction for how much it's going to cost a student entering a private four-year institution if they start in the year 2025. Okay, we're going to do the same thing for public institutions. There's our best fit polynomial, and we're going to replace the variable x with the number 54. A little more complicated, but not too bad. You can use your calculator or that Excel spreadsheet to compute what this value is going to be to give you your prediction for a student entering a public four-year institution in the year 2025. Great. Now, one last thing, we want to use our Excel data to see how the numbers validate this part of the activity, which is the same as the title of this slide. Why is college tuition over 100% higher than it was 20 years ago? And so I want to verify where the four numbers that you're seeing here are coming from. So I'm going to go back to that Excel spreadsheet one more time so we can see where those numbers have come from. Okay, so here is our Excel spreadsheet. 20 years ago would be a student who entered in the year 1999 or the year 2000. And so we see that if they entered a private institution, they would have paid on average a tuition of $23,460, and a public institution an average of $5,080. So that was 20 years ago. So that's two of the numbers we're going to see on that next chart. And then scrolling down, here are our averages for a student ending in 2019-2020. So for a private institution, the change is from the $23,460 to $36,880. And for a public institution, the change is from $5,080 to $10,044. So those are the four numbers you're going to see on that chart. So let's go back to PowerPoint. Okay, so that's just verifying where those four numbers have come from. All right, so why do we say that college tuition is over 100% higher than it was 20 years ago? Well, let's look at the change in private tuition. So the cost of private tuition, to figure out how much it's up by, we want to take the difference in the 20 years. How much has it changed in 20 years? So 36,880 minus 23,460, and then divide by that initial amount of 23,460. And when we do that, we see that the cost of private tuition is up by 57%. Now that's a big increase in 20 years, but it's not the 100% that is the title of the slide. So what I want you to do is do the same computation for public tuition. How much is public tuition up by? So do that computation and see if that validates the title of the slide. How much has public tuition grown by? Okay, now if you're curious about the why, so hopefully that validates what I'm saying, but But what is the why? Why is college so much more expensive? So there's a nice link to an article here if you're curious and want to read more. But some of the things that have come into play are things like a surge in demand, that more students are wanting to go to college, an increase in financial aid, and college is taking advantage of that, knowing that students have more opportunity for financial aid and therefore feel validated in raising their college costs. A lack of state funding, which has certainly come into play more for public tuitions than private. And then ballooning student services. So these are things like academic support, counseling services, healthcare, other administrators in the college dorms and facilities to make colleges appealing to students. All of these types of student services have really ballooned in the last 20 years. And so all of these things are really the why behind why college has become so much more expensive than it was 20 years ago. Okay, moving on to part two. So part two of this activity is going to explore the impact of interest rates, and we're going to use here an online calculator. There's a link that you see there at the bottom, so you're going to need that online calculator to help answer a couple of these next questions. So here we go. Scenario number one. So imagine the following scenario. John attended college between 2004 and 2008, and Jennifer is planning to enroll in the fall of the current year, so in 2020, and expects to graduate 4 years later. We're going to assume that the amount borrowed for each of them constitutes 50% of their tuition. Okay, so to fill in this chart, we need to start by figuring out the amount each paid or will pay in tuition. So to determine the amount of tuition that John and Jennifer are going to pay, because we are assuming that they're attending a 4-year public college, we're going to need that polynomial that we created in Excel, and I included it here for us. Okay, so there's our function. Now remember that for us, x equals 0 was 1971. And so if John entered college starting in the year 2004, then that's going to relate to x equals 33. So for John, who attended college between 2004 and 2008, we need to calculate f of 33, f of 34, f of 35, and f of 36. And then we're going to average those four numbers. Okay, so for example, for f of 33, we'll take that polynomial, we'll replace the x with the number 33 and do the computation just so you can make sure you're on the right track. You should get $6,287.74 as your f of 33. And then you're going to do the same thing for 34, f of 35, f of 36, and average those four numbers together, and that's going to give you the amount of tuition that we assume that John paid. Okay, so just to make sure you're on the right track, for John, you should get around $6,674. Okay, for Jennifer, because we're assuming that she is planning to enroll in 2020, so 2020 will correspond to x equals 49. So for Jennifer, you want to find the average of f of 49, f of 50, f of 51, and f of 52. So there's her f of 49 just to get you started. Okay, so that's your tuition amounts. Okay, the next part of the chart is the loan amount. So to determine the loan amount, we need 50% of the tuition rate that we just found, times 4, since we're assuming that they borrowed 50% and attended or will attend college for 4 years. So for John, we found that his tuition was on average $6,674. We're assuming that he borrowed 50%, so times 0.5, and that he did that for 4 years. So John's loan amount then becomes $13,348. And you'll do the same thing to compute the loan amount for Jennifer using the tuition amount that you found for Jennifer. Okay, the hard part is over because the rest of this chart, we're going to use our online calculator to find our monthly payment, the total interest paid, and the cumulative payments. Okay, so we've got these amounts for John, his tuition amount, his loan amount, the term of the loan, and his interest rate of 6.8%. Okay, so I'm going to go to my online calculator. Okay, so here I am at our online calculator. I'm going to go to our loan payment link and just scroll down. Okay, so John's loan amount was $13,348. His interest rate was 6.8%. We are assuming the term of the loan is 10 years, and they're requiring a minimum payment, so I'll just type in $50 for that and click calculate. Okay, so this now gives me all the rest of the information I need for my chart. So we see that John's monthly loan payment is going to be $153.61. His cumulative payments, $18,433.20, and the total interest John is going to end up paying $5,085.20. Okay, so I'm going to add those three values into our chart for John. Okay, so there's the information given to us from our online loan calculator, and you'll do the same thing to complete Jennifer's information. Okay, now here are some questions. In referring to John and Jennifer, who pays less in interest and by how much? And after repaying their loans, what are the cumulative payments of John and Jennifer? Now, in reference to that previous question, is this result in line with or contradictory to the interest rate that each borrower got? Notice Jennifer has a much lower interest rate, 5%, compared to John's 6.8%. So Jennifer has a much lower interest rate, but you should see that Jennifer ends up paying much more in total interest, even though she has a lower interest rate, simply because the amount that she had to pay in tuition was that much higher than John's. Okay, last piece, and it's the easiest. Scenario 2. So imagine that John and Jason attended college concurrently, so at the same time. They borrow a comparable sum of money. However, Jason received a lower interest rate on his loan, and assume that the amount borrowed constitutes 50% of the tuition. Okay, so we get to use all of our same information from John that we had from scenario 1. Since Jason and John attend college at the same time, then they will pay the same amount in tuition. And since they both borrow 50%, then they have the same loan amount as well. So the only difference between Jason and John is that interest rate. And so what you should do is you should use that online calculator to complete the chart to fill in the rest of the information for Jason. And now, since the only difference is that interest rate, see how much does Jason save in interest compared with John. And so the point here is to encourage you when you're thinking about your student loans to make sure that you're looking around for that best interest rate possible. So wrapping up this lesson on student loans, note that this is a very political issue and we are going into an election year. So as you get ready to think about which candidates you're going to vote for, you should definitely learn where different candidates stand on the issue of student loans. And so there are lots of articles available you can read to find the proposals of various candidates. And so I encourage you to really do your homework on that moving into the election year and figure out which candidates you think are going to be the best for you on the issue of student loans. Thanks, guys. Let me know if you have any questions. I'll see you in class.